Hello students, welcome to our today's discussion. I did promise yesterday that we are going to look at properties of electromagnetic waves. Before we look at this, remember that the electromagnetic waves, what is their definition? What are some of their examples? What is electromagnetic spectrum? And how do we arrange them in terms of their frequencies, in terms of their energies, or in terms of their wavelengths? Get that in the previous video. Subscribe, like, and share with other students. Let us look at properties of electromagnetic waves. These electromagnetic waves, which are 7 in number, are again having 7 properties that I'm going to discuss here. Number 1, the first property is that they are transverse in nature. They are transverse in nature. All electromagnetic waves are transverse in nature. That is the first property. Number 2, they do not require material medium for transmission. So this simply means that they can travel in a vacuum. So they don't require material medium for transmission. Number 3, the third property is that they carry no charge. They carry no charge. They carry no charge. Hence, they are not affected. Hence, they are not affected by either electric or magnetic fields. So we are saying that all the 7 electromagnetic waves has no charge. Hence, they are not affected by either electric or magnetic fields. The fourth property, we say that they undergo interference. They undergo interference, reflection, refraction, diffraction, and polarization effects. So all electromagnetic waves can undergo interference, they can be reflected, they can be refracted, they can be diffracted, and at the same time they can undergo polarization effects. Research on what is polarization. The fifth property of electromagnetic waves is that we are at the fifth property. They travel through space. They travel through space. That is vacuum with the speed of light. With speed of light, i.e. c is equal to 3.0 by 10 power 8 meters per second. So all the 7 electromagnetic waves travels through space with the speed of light, which is denoted by small letter c, which is 3.0 times 10 power 8 meters per second. Let us look at the sixth property of electromagnetic waves. Sixth property is that they obey the wave equation. They obey the wave equation. All electromagnetic waves obey the wave equation. C is equal to F lambda. C here is the speed of light, which is a constant. F is the frequency of the wave, and lambda is the wavelength. The final property of electromagnetic waves is that they possess energy. They possess energy in different amounts. In different amounts according to the relation. According to the relation E is equal to HF, where H is Planck's constant. This is a constant, Planck's constant. Its value is H is 6.63 times 10 power negative 34 joule second. And F is the frequency of the wave. So we are saying that our electromagnetic waves possess energy in different amounts according to the relation E is equal to HF. That is, energy is given by H is Planck's constant multiplied by the frequency. The value of Planck's constant is 6.63 times 10 power negative 34 joule second, and you know frequency is always given in Hertz. The last two properties is giving us formulas. It means we can try to understand these two particular formulas. So let us note the formulas down so that we can look at some few examples that involves calculations of the electromagnetic waves. Let us look at this. Note, we have said that the sixth property is that all electromagnetic waves obey the wave equation C is equal to F lambda. This is a parent formula. From this formula, we can see that lambda is equal to C all over F, and we can also see that F is equal to C all over lambda. If somebody wants to get minimum frequency or maximum frequency, for minimum frequency it will be C all over maximum wavelength. Why? Because frequency and wavelength are inversely proportional. The final 5 here, we can say, how do we now get the maximum frequency? It will be speed of light divided by the minimum wavelength. So number 2, 3, 4, 5 is derived from the parent formula. Let us look at the property number 7, which we've said is that, let's have it this way as number 6 now. Energy is given by Planck's constant H times frequency of the wave. So this is again another parent formula. We can understand from this formula that if I want to get energy and I've been given, let's say, wavelength, so E is equal to Hc all over lambda, because this F can be substituted with the C all over lambda. On the same note, if I want to get maximum energy, it will be Planck's constant times maximum frequency. This is because energy and frequency are directly proportional. This therefore tells us that this maximum energy can also be given by, look here, we have maximum frequency is C all over minimum wavelength, so it can be Hc all over minimum wavelength. We are just playing around with the formulas. Number 10, if I want to get minimum energy, I'll take Planck's constant times minimum frequency. Reason I've said, energy and frequency are directly proportional. Finally, we can agree that minimum energy can be given by the formula. Look here, minimum frequency is given by C all over maximum wavelength. So it can be Planck's constant multiplied by C divided by maximum wavelength. So that is the understanding of the two formulas. But please, the formulas are only two. C is equal to F lambda, E is equal to HF. The rest are simply manipulation of those particular two parent formulas. With this, now we can try and solve maybe two examples before I give an exercise. Let us look at few examples. Let us look at examples number 1. The first example. Examples. Number 1. A radio station is transmitting. A radio station is transmitting. A radio station is transmitting at a frequency. At a frequency of 15.42 megahertz. Capital M is mega, and you know times 10 power 6 is mega. Full stop. Calculate the wavelength of the transmission. The wavelength of the transmission. Calculate the wavelength of the transmission. In bracket, C is equal to 3.0 times 10 power 8 meters per second. The speed of light is a constant which has been given. How do we tackle this particular problem? Solution. Let us look at what we have been given. We have been given the frequency as 15.42 megahertz, which we must understand to be 15.42 times 10 power 6 hertz. Mega is times 10 power 6. We have also been given speed of light to be 3.0 times 10 power 8 meters per second. They now want us to get what? Wavelength. So we shall have the wave equation C is equal to F lambda. Let us do the substitution in that formula. C is 3.0 times 10 power 8 is equal to the frequency 15.42 times 10 power 6 times lambda. So what do we do to get the wavelength? Our wavelength will be divide both sides by 15.42 by 10 power 6. That will be 3.0 times 10 power 8 all over 15.42 times 10 power 6. Here, ensure that you use your calculator very accurately. For you to use your calculator accurately, ensure that the numerator is placed in a bracket, then denominator is also placed in a bracket, because our scientific calculators follows BODMAS. If you press accurately, we get the wavelength to be 19.46 meters. Our answers should be to at least 4 significant figures, at least. I hope understood. Try to key the data in the calculator to get 19.46 meters. Let's look at the second example. Number 2. Example 2. Green light has a wavelength of 5 times 10 power 6 meters. Full stop. Calculate the energy it emits. Calculate the energy it emits. In brackets, H is equal to 6.63 times 10 power negative 34 joule second. C is equal to 3.0 times 10 power 8 meter per second. How do we solve this particular problem? In terms of data that we have been given, wavelength has been given as 5 times 10 power 6 meters Planck's constant h has been given as 6.63 times 10 power negative 34 joules second, and speed of light has been given as 3.0 times 10 power 8 meter per second. They want us to get the energy of this particular green light. We know that energy is given by Planck's constant times frequency, but frequency is c all over wavelength. So this therefore tells us that energy is hc all over lambda. We do our substitution. 6.63 times 10 power negative 34 times 3.0 times 10 power 8 divided by the wavelength, 5 times 10 power 6. So we get our energy as what? I've said in such huge number calculations, put the numerator in bracket over put the denominator in bracket so that you can get the right answer. Key in and get 3.978 times 10 power negative 20 joule, because the unit for energy is joule. I believe that is well understood. So therefore, I think at that particular point, I can give some assignment that you try by yourself. Let's look at exercise number 1. Exercise number 1. Number 1, an X-ray machine produces radiation of wavelength An X-ray machine produces radiation of wavelength 1.0 times 10 power negative 11 meters. Stop. Calculate part A of the equation, the frequency of the radiation. The frequency of the radiation. In bracket, C is equal to 3.0 by 10 power 8 meter per second. Part B of the equation, its energy. Its energy in bracket, H is 6.63 times 10 power negative 34 joule second. Can you try that question? Let me find the answers in the comment section for marking. Let us have number 2 as our last exercise. Question 2. A radio is tuned into a radio station 144 kilometers away. Full stop. Part A of the equation. How long does it take to reach the receiver? How long does it take to reach the receiver? Question mark. In a bracket, C is 3.0 by 10 power 8 meter per second. Part B of the question. If the signal has a frequency, of 980 kilohertz, small k, kilohertz, comma, how many wavelengths is the station? How many wavelengths is the station away from the receiver? away from the receiver. You can try that. Again, if you find answers, you can also key it in the comment section. That's okay. So with that, we are done with the properties and basic calculations involving electromagnetic waves. If you find a problem, don't hesitate to call me on 0707 353 329. You can call, text, or WhatsApp via this so that we can help you in that particular exercise. At the same time, subscribe to the channel to view the next video tomorrow. Tomorrow, we shall be looking at production and detection of electromagnetic waves. Production and detection of electromagnetic waves. That will be our major concern tomorrow. Otherwise, I wish you all the best. See you tomorrow. Goodbye.